Okay, we're back, and today we're going to discuss um, the gaining and losing of electrons and forming neutral molecules. So, in the previous video on valence electrons, I discussed how metals want to lose electrons and nonmetals want to gain electrons. So, if we look at these first two groups, the alkali metals and the alkaline earth metals, we know that the alkali metals has one valence electron and that the alkaline earth metals have two. Well, these are both metals, except for hydrogen. It's not a metal, but we're just going to disregard hydrogen for now while we're talking. But all of these others are metals, and they want to lose electrons. And they want to have stable noble gas electron configurations. And the only way to do that is to lose or gain. Well, if they were to gain electrons, they want to gain all the way up to 8 valence electrons. Well, if an element has 1, that means they'd have to gain 7. So that element either has to gain 7 or lose 1. And when we talk energy, it's easier to just lose 1 than it is to gain 7. So these elements here are going to lose 1. These elements in group 2, okay, down here, the alkali earth metals, they would have to come all the way over here to 8 as well. And in order for them to do that, they would have to gain 6. But it's easier for them to lose 2 than gain 6. So having said that, let's take a look at the Lewis dot. So I'm going to be drawing Lewis dot diagrams here. Okay, Lewis dot diagrams. And what a Lewis dot diagram is that it shows the symbol of the element. So for example, I'm going to use sodium. Okay, it uses the symbol of the element and then draws how many electrons that are, or how many valence electrons it has. Well, sodium is in group 1A, so it has 1 valence electron. So this is the Lewis dot diagram of sodium. And lithium is the exact same, except it's Li instead of Na, and it has 1 valence electron. Well, both of these elements want to lose electrons. So when they do, sodium as a neutral atom has 11 protons, or 11 positive charges. It has 12 neutrons, and it has 11 electrons. And I believe I covered this in the last video. But it's going to lose 1 electron. It's going to lose this 1 valence electron right there. So when it does lose that electron, this 11 now becomes a 10. Okay? Now it has a 10 electrons with it. Okay? Causing there to be more positives. There's 11 positives and 10 negatives. We don't worry about the neutrons in this when we're talking about ions. 11 positives and 10 negatives. Therefore, in the end, there's more positives. How many more? There's 1 more. So, sodium is indicated like this when it forms an ion, Na, 1 positive. And we don't ever need to write the 1. We could just leave the 1 out. And the exact same thing is true for lithium. It loses 1 electron, so lithium ion is indicated Li plus. So what about these elements in group 2? Well, good question. Let me erase everything we got here. And group 2, if we look at group 2, let's start with magnesium. I like magnesium. Magnesium does some great chemical reactions. It's a main component in fireworks. And magnesium here is in group 2, so it has 2 valence electrons, 1, 2, and there's a reason I'm sticking them on the opposite sides, but we don't need to worry about that for now. And it's going to lose both of these valence electrons. It's going to lose both of them. So when it does, magnesium as a neutral atom has 12 protons, it has 12 neutrons, and it has 12 electrons. Well, it's going to lose the 2 valence electrons, bringing this down to 10 electrons, causing there to be 12 positives, 10 negatives. Overall, there's 2 more positives, so we're going to indicate it as Mg2 plus. And the same thing is true for everything in that group. Beryllium, Be2 plus when it makes an ion. Calcium, Ca2 plus. They all lose 2 electrons. Now, one thing that's very confusing for some people is that this plus is it's positively charged, and you can never change the number of protons, because if you do, you change the element altogether. So we're only changing electrons here. We're only changing those. Plus does not mean it gained. Whenever you see a positive ion like magnesium ion, beryllium ion, calcium ion, that indicates that it has lost electrons. So what about those metals that, or excuse me, those nonmetals that gain electrons? Well, those are right here. There's more than them, but I'm just showing you groups 6A and 7A, which is the oxygen group and the fluorine group. Oxygen group here is 6A, indicating that it has 6 valence electrons. So I'll show you what they look like. We have oxygen here, and it has 6 valence electrons. 1, 2, 3, 4, 5, and 6. Now it's not going to lose all 6 of those. What it's going to do is essentially gain 2. And it's going to put 1 here and 1 here to make it a full 8. So it's going to gain 2. So when it does, oxygen normally has 8 protons, 8 neutrons, and 8 electrons. Well, it's going to gain 2. So when it gains 2, it's now going to have 10 electrons, causing there to be 8 positives, 10 negatives. When there's 8 positives and 10 negatives, there's more negatives. So we indicate oxygen as O, and it's got 2 more negatives, 2 minus. And the same thing is true for everything else in that group. Sulfur, 2 minus. Selenium, 2 minus. Okay. Well, that's not the case for group 7. Group 7 is the halogens. And the halogens do not gain 2. They gain 1. They gain 1. So let's take a look at fluorine. Fluorine would have 7 valence electrons. So by default, it has 1, 2, 3, 4, 5, 6, 7. And it wants to gain 1, which when it does, it's going to go there. So by default, a neutral fluorine atom has 9 protons. It has 10 neutrons, and it has 9 electrons. Well, it's going to gain 1, causing this to be 10 electrons, giving it 9 positives, 10 negatives. Overall, there's an overall charge of 1 negative. So fluorine will be indicated by, fluorine will be indicated by F minus. And that is true for everything else in that column. Chlorine, Cl minus. Bromine, Br minus. Iodine, I minus. So that is how we are forming those ions, by gaining and losing electrons. So let's talk about what happens when we take an element that loses electrons and gains an element that gains electrons. So for example, let's go with sodium that loses electrons and chlorine that gains them. Okay? Sodium by default is going to lose 1, so its charge after it's lost 1 is positive. Chlorine is going to gain 1, and its default charge is going to be minus. Well, these two actually form a great relationship. Sodium here wants to lose an electron, lose 1 electron. Chlorine here wants to gain 1. So they form a great relationship because sodium says, hey, I've got this extra garbage here and I don't want it. And chlorine says, hey, I'll take it. So they form actually what we call an ionic bond. Okay? And this ionic bond is when you have a metal and a nonmetal that where the metal loses the electrons, the nonmetal will gain the electrons, and there is an electrostatic attraction. So there's an electrostatic attraction between them because one loses and the other one gains. So they form this electrostatic attraction by the losing and gaining of electrons. But let's write a neutral molecule. Now we have the sodium ion, which is Na+, and we have the chlorine ion, which is Cl-. Now if we take a look here, let's look at the charges on these. This is one positive, this is one negative. So when these two join together, they are equal in size, the number 1, and opposite in charge. So when that happens, you're essentially done. The answer of a neutral molecule between sodium and chlorine is NaCl. Okay? It only takes one sodium and one chlorine to form that relationship, and you get this neutral molecule of NaCl. This, by the way, is table salt, which you all have heard of before, table salt. So now what about if we have something like magnesium, which is 2 positive, and we have chlorine, which is negative. These are not equal and opposite. This has 2 positives, this only has 1 negative. Well, we need to balance them out. So a method I like to use is the crisscross method. Okay? And what we do here with the crisscross method is if it's 1, we don't do anything. But if it's other than 1, we're going to take that number. I'll change colors here so you can see. We're going to take that number and we're going to move it right here on the other side of this. We're right 2. And now that is our formula. Our formula is what you see there, getting rid of the charges. We never include charges. So our formula is MgCl2. MgCl2. And the reason we have 2 for the chlorine is we need 2 times the 1 negative to balance out the 2 positives. We need 2 negative charges to balance out the 2 positive charges. Here's another example of that. Let's say we have, let's just go with calcium. Calcium Ca2+, and we got fluorine F-, same thing. The 2 is going to come down here to the F, right there, and that is our formula, getting rid of the charges, CaF2. Now let's try it if we have some elements on the other side that have multiple charges. So for example, let's say we have sodium, Na, sodium ion, which is Na+, and we're going to combine it with oxide, which is 2-. Okay? And in this compound, we're going to make sodium oxide. We're going to do the same crisscross method because they're not equal and opposite. They are opposite, positive over here, negative over here, but they're not equal. This is 2 and this is 1. So the 2 is going to attach to the sodium, okay, and the 1 is not going to do anything. So now it's going to be Na2O, and that is sodium oxide. Now sometimes in chemistry we deal with anions and cations. Remember, a cation is an ion with a positive charge. So an ion with a positive charge. Okay. And an anion is an ion with a negative charge. Well, sometimes we have Most of these are considered anions, but sometimes we have anions that have more than one element. For example, this right here is just oxide. It's oxygen that has gained 2 electrons, so that is an anion, but it is a monatomic anion. Well, we have these other things called polyatomic anions. And these polyatomic, poly meaning multiple. Okay? And they are multiple. They have multiple elements attached to them. For example, the sulfate anion is SO4, and it has a -2 charge, 2-. It's one element of, or one atom of sulfur and 4 atoms of oxygen. But it has 2 more electrons than normal. It's gained 2 electrons. Well, sometimes these are involved in making compounds. So let's try one where we have a polyatomic anion. Let's go back to, let's just say we have calcium. And calcium ion is Ca2+. It's in group 2, and it's going to lose 2 electrons because it's a metal. And we're going to combine it with the sulfate polyatomic anion. And as we notice here, look at both sides. The positive is 2+, the negative is 2-. Okay? They are equal in size, 2 and 2, and the opposite in charge, positive, negative. Therefore, we do not have to do anything. We can just scratch these off and combine everything together. And our actual neutral molecule is CaSO4. Calcium sulfate. Now let's try one that has a little more complexity to it. Let's take our good friend Mr. Magnesium, which as an ion is Mg2+. It's in group 2, it loses 2 electrons. And let's combine it with the polyatomic anion called phosphate, which is PO4, and the charge on this is 3-. Now let's just recap here. This is 1 magnesium. This is 1 phosphorus and 4 oxygen. And as a group PO4, the overall charge is that it gains 3 electrons. It gains 3 electrons. Well, we can do the crisscross method here, same as before. The 2 is going to come all the way down here to the end. And the 3 is going to go all the way over here. Here's the problem. Is that some students will write it like this. Mg3 PO4 3, or they may write it Mg3 PO7, thinking that we need to add the 2, or excuse me, not 7, 6. Add, and this right here would not be 3, this would be 2. Add the 2 to that when that's not the case. We're not going to be doing any adding at all. Okay? What this says is this 2 needs to come down here and multiply everything over here by 2. Everything by 2. So some would even write it like this. Mg3 P2O8. This is these first 2 are incorrect. Okay, I would not do either one of these. Okay, these first 2 are incorrect. This third one is, it's somewhat okay. It is going to be 2 phosphorus and it is going to be 8 oxygen, but it doesn't really still show that we have phosphate. So the correct way to indicate this in chemistry is really going to be Mg3 parentheses PO4, just like that, close parentheses, and we're going to multiply everything on the inside of this parentheses by 2. And this is the correct way to indicate that in chemistry. This is magnesium phosphate. Okay? And if you calculate it out, everything is balanced. Because magnesium is 2 positives. Excuse me, 2 positives, not 3. 2 positives. 3 times 2 positives is 6 positives. And phosphorus over here is 3 negatives. 2 times 3 negatives is 6 negatives, and that balances each other out. So this is a neutral molecule, leaving it just like so. Mg3 parentheses PO4 close parentheses 2. So why don't we take a couple of minutes and do a couple of practice ones together. So I'll post 4 here on the screen for you, and just take a minute to go ahead and practice them. So now that we've had a second to try these 4 here, let's go ahead and combine them together. I'm going to write in a different color. I'm going to write in blue. We've got calcium 2 plus because it's lost 2 electrons. We've got nitrate because it has gained 1 electron. We're going to use the crisscross method. Okay, and we have a polyatomic anion here, and because we're moving a number over there behind the polyatomic anion, we're going to have to put parentheses there. Okay, so our answer is really going to be Ca parentheses NO3 close parentheses 2. Calcium nitrate. Next up is aluminum Al3 plus with OH minus. Okay. We are going to do the crisscross method. Again, the 3 is going to come down and go over here, but we're putting a number behind a polyatomic anion, so we're going to have to use parentheses again. We don't do anything with the 1, so there's our answer. AlOH3, aluminum hydroxide. Next up, Li plus, it's lost 1 electron. BrO3, this is the bromate, it's gained 1 electron. They are equal and opposite, so we don't have to do anything. We can just scratch them off and write what we have. LiBrO3, lithium bromate. Next up is silver, Ag plus and N3 minus. They're not equal and opposite, so we have to crisscross. The 3 is going to come over here. I'm going to write the 3 there. We don't have to do anything with the 1, so there's our answer. Ag3N. Silver nitride. So that is the end of combining ions in order to make neutral molecules. The next step is going to be taking those neutral molecules, identifying the cation, identifying the anion, and then writing the name. So we're essentially going to do this whole process in reverse and then write a name. So check back in on that video.